Hello everybody, welcome back to another video. Today we're going to be solving FRQ number 3 for the AP Calculus BC 2025 exam. Let's get right into it. So let's read FRQ 3. A student starts reading a book at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the student reads is modeled by the differentiable function r, where r of t, a function of time, is measured in words per minute. Selected values of r of t are given in the table shown. And you can see right here, we have 0 to 8, 10, and r of t, which is words per minute, is 90, 100, 150, and 162. Part A. Approximate r prime of 1 using the average rate of change of r over the interval 0 is less than equal to t, which is less than equal to 2. Show the work that leads to your answer. Indicate the units of measure. If you need to pause to read the question or understand it better, I suggest you do so because we're going to be diving right into the solution. So what we do know is r of t is describing words per minute, and it's a differentiable function. But the key word in the problem that you should probably underline as you read is rate. That way we know r is describing the rate at which what is being read and in words per minute. So we can approximate r prime of 1 as part A suggests. So what is r prime of 1? They want us to use the average rate of r from the interval. This is very simple, and you can do this even with some basic algebra 1 knowledge. If you remember, it's just slope over that interval. So we can say r prime of 1 is approximately, using the approximate equal sign, equal to what? We're going to have y2 minus y1 over x2 minus x1. So we're going to have r of 2 minus r of 0 minus 2 minus 0 over 2 minus 0. This is going to give us 100 minus 90 all over 2. And that's the average rate of change over that interval. So if I have a function, for example, and I have this point and this point, the average rate of change based on this interval is the slope of this line connecting those 2 points. And that's exactly what we're doing right here. So we can calculate this, and this is no calculator, so you have to do all this. But remember, you do not have to simplify for College Board, so you could have left your answer like this, and that would be fine. But the answer was 5. Now, by the way, they also want us to include the units of measure. This is simply going to be words per minute. Because we have words per minute actually, because r of t is described in words per minute, and the derivative is simply going to be words per minute, since this is another function of time, once again. Yeah, and similar to how it works in physics as well, when we have velocity is meters per second, and then we differentiate, we get meters per second squared. So it's the same concept applying here. Now, part B. Must there be a value c for 0 is less than c, which is less than 10, such that r of c is equal to 155? Justify your answer. Keyword justify. If you don't justify, you're going to be losing a lot of points. So immediately this should be going off in your mind. If you see must there be a value of c, you should be thinking of EVT, IVT, or MVT. Those are your different value theorems, and EVT definitely, you should not be even considering that because that's thinking about extreme values on an interval, so that's not necessary right now. But what is needed for this problem is IVT, the intermediate value theorem. And the intermediate value theorem guarantees that all values between a certain interval on the y-axis will exist if you have an interval like this. And we'll explore what that means in a second. So let me just draw this graph out right here. Now, if we have a function that is continuous, IVT guarantees that all of the values between here, let's call this 1 and 9, all of the values between 1 and 9 will exist on the function. If there's some value 8 and this is a continuous function on this interval from here to here, then it's guaranteed that that point 8 will lie on that function. So, using this knowledge, we can simply write a long statement using words. The question asks, must there be a value? So we can simply say yes. Since r, and how do we know that r is continuous in the problem statement? It says that r is differentiable. It's a differentiable function r, and differentiability implies continuity. So we can say since r is differentiable, this implies r is continuous. Continuous. There we go. Now, you can simply just directly mention the IVT theorem, and that'll really clarify what you're talking about. But if you don't mention it, you'd have to list all of the requirements. Well, you still have to list all the requirements anyway, but you'd have to list how that works and why that works. But mention IVT guarantees, oops, I cannot spell today, that R of t. What is IVT guaranteeing? That R of t is going to attain all the values between, and what are our points on the interval? We have R of 0 and R of 10, because that's the interval that they give us. R of 0 and R of 10. And if you really want to, you can also specify the values of these, because you'll see in a moment why this is true. R of 0 is 90, and R of 10 is equal to 162, given by the table. 162, and R of 0 is 90. And we can guarantee this because the value they gave us was 155. So that lies between 90 and 162. Now we can simply state, we have to state that fact, which I just said, that 90 is less than 152, which is less than 155, which is less than 162. So because 90 is less than 155, which is less than 162, C must, or you could say there is a value C. There exists a value C for 0, the interval which they gave us, not really needed, but just for the sake of writing it all out, such that R of C is equal to 155. So this is a little bit wordy. You could have simplified this a little bit, but essentially the key points behind this, in what I believe, is that you have to say that R is continuous because it is differentiable. That's one of the key points that they want you to touch on. That's why they gave you differentiability. You also have to mention IVT, and what is a guarantee? It guarantees that R of t will attain all the values between the bounds, 190 and 162, because 155 is in between that interval itself. So those are the key points right there. And the answer is yes. If you didn't get yes, then unfortunately you won't get any points for that question. Now, part C. Part C asks, use a trapezoidal sum with the 3 subintervals indicated by the data in the table to approximate the value of the integral from 0 to 10 of R of t dt. Show the work that leads to your answer. Show the work means don't leave a blank answer, or don't leave just a blank answer without any work. So show your work. Now, we can simply start off with the integral that they give us, 0 to 10 of R of t dt. We'll get my approximate equal sign right there. Now, what is a trapezoidal sum? This is simply going to be a Riemann sum. And if you're a Calc BC student and you just took the exam, this should have been really easy for you. Riemann sums are quite easy. All you do is you want to subtract this amount, or this amount from this amount, and you want to multiply by the height. And we're going to explore this really quickly as a review for people who might not have taken it or are taking it in 2026. Who knows? But a Riemann sum is essentially taking a rectangle and approximating the sum just by summing up a bunch of rectangles. So if I'm summing a bunch of rectangles like this, you'll notice that the height of these rectangles is dependent on the left side of the rectangle itself. So this is what we call a left Riemann sum, just like this. And now if you do the same thing for the right side, then what you're going to do is you're going to align this to the value of the actual function. You can bring this down here, this one down here. Now, what is a trapezoidal sum? Trapezoidal sum is a little bit tricky, but essentially it's quite simple. Let me draw it out. Just like this. Oops. So I have my same curve like this. A trapezoidal sum is exactly what it sounds like. It's a trapezoid. Oh my goodness, my y-axis is a little tilted. Just like this. Straight line down. Now, a trapezoidal sum looks like this. Now, a trapezoidal sum looks like this. Now, a trapezoidal sum looks like this. you want to start at this point right here. You want to go straight down. Then you want to take whatever width you're going, but my second point for this rectangle supposedly is going to lie on the function as well. I bring that straight down, and then I connect these 2 points with a straight line. Then I repeat. I go down here. I have a trapezoid, just like this. And then I'd repeat here, do this. I go all the way down. And then you get the idea. You sum like this in this continuous manner, and it gives you a pretty nice approximation of the actual sum. Now, how do we find the area of a trapezoid in this case? It turns out the area of this is going to be simply, let me use blue, this width, we'll call this W, and the midpoint of these two. So it's going to be this plus this over 2. That's the value of that. You want to multiply this height, this h, by the width, and you're going to get the area of the trapezoid. It's very handy. And there's more proof on that. It's just simple geometry. You want to take the midpoint and you want to multiply by the width, and you'll get the area of the entire thing. Simple geometry, but it's pretty intuitive as well. If you're still not believing me, imagine you cut out that part, you rotate it, and you add it like that, and there you go. That's how you get your answer. Now, with this new knowledge, all you have to do is write it out just like it asks. So you want your width in this case is going to be 2 minus 0 for the first rectangle, and your height is going to be exactly what I said, 100 plus 90 over 2. Then we want to add our second rectangle. It's going to be, the width of it's going to be from 2 to 8, so it's going to be 8 minus 2 in width. The height is going to be this plus this over 2, 150 plus 100 over 2. Then we're going to have 10 minus 8 and 162 and 150 plus 10 minus 8, 162 plus 150 all over 2. Now, let's simplify. Now, if you caught me right there, you would have realized that simplifying is the biggest mistake. A lot of you guys must have wasted time by simplifying your answer, and that didn't leave time for the other parts. On the AP exam, you don't have to simplify. If you leave your answer right like this and you wrote all the right numbers, you're going to get full credit for it. So yeah, that's all you have to do for part C. Now, lastly, we have part D. Part D, a teacher also starts reading at time t equals 0 minutes and continues reading for the next 10 minutes. The rate at which the teacher reads is modeled by the function w, defined by w of t is equal to negative 3 over 10 t squared plus 8t plus 100, where w of t is measured in words per minute. Based on the model, how many words has the teacher read by the end of the 10 minutes? Show the work that leads to your answer. So, Calc student, once again, this should be going off in your mind. How many words has the teacher read by the end of the 10 minutes? This is a simple accumulation problem. This is just an integral. If this function is telling you the rate at which the teacher is reading in words per minute, the number of words she read is simply the integral of it, because the words per minute is the derivative of the number of words she read in total. Yeah, if you didn't catch that, all I'm saying is if you integrate the words per minute, you're going to get the total amount of words, which is accumulation. So our answer is going to be 0, the integral from 0 to 10 of w of t, which is negative 3 over 10 t squared plus 8t plus 100 dt. You can simply integrate this by using your power rule, and that's all you need. So you'd have negative 3t cubed over 30 plus 4t squared, because you want to add 1 and you want to divide by the new exponent. Then you have plus 100t, and it's going to be bounded by 0 to 10. And you want to simply plug in all the values. You're going to get negative 3 over 30 times 10 cubed plus 4 times 10 squared plus 100 times 10, minus, and then when we plug in 0 into all of these, you're going to get 0, so you can just remove that minus. And you don't have to simplify this at all, to be honest, but for the sake of this, I will. This is equal to negative 100 plus 400 plus 1,000, and this is equal to 1,300. And what's our units? Words, because w of t was given in words per minute. So when we accumulate and integrate, we're going to get the total number of words that the teacher read at the end of the 10 minutes. Yeah. Hopefully, FRQ 3 was an easy one for you. The no calculator ones are typically easy. You don't have to overthink them too much. It's fine if you haven't. If you're watching this for next year, good luck. So these problems are really easy. Just practice them a little bit and you'll get the hang of it. If you have any questions or if I didn't clarify anything enough, let me know in the comments down below. Thank you guys. See ya.